talk about centripetal acceleration, centripetal force and circular motion. If you have an object in motion, it's going to have a velocity. But remember, velocity has a direction. So if this object is actually going around in a circle, then the velocity is changing. And whenever there is a change in velocity, remember, there is going to be an acceleration. The acceleration is determined by the change in velocity over the change in time. So this type of acceleration, where it's going around in a circle, this has got a special name. This is called centripetal or centripetal acceleration. Now, centripetal acceleration, what do we know about it? How big is well, acceleration, we could put a little c down there, we'll put a subscript c in to say this is centripetal acceleration. Well, what do we know about it? Well, we know it's related to the velocity. So the faster you're going, the bigger the changes as you go around each corner. In fact, if you work it out, it's going to be related to the square of the velocity. And the other thing that's really important, hopefully you'll notice this from experience, is the radius of the corner. If you're driving in a car and you go around a tight corner, you have to hold on a lot tighter than if you're driving around the same speed or same velocity around the big corner. So the centripetal acceleration is going to equal the velocity in meters per second squared divided by the radius in meters. And if you do a dimension check on this, you end up with meters per second squared divided by meters. So that ends up with meters per second squared. Just checking. And that's going to give us our centripetal acceleration. Now dimension check shows us the velocity, and that is meters per second squared, which is exactly what we're expecting. Okay, that's cool. Now, the other thing is, an object in motion stays in motion, and an object at rest remains at rest, unless a force is applied. So in this case, there must be a force that is being applied to this force. And this is going to be the centripetal force. Now there's a couple of things we know about the centripetal force, or the centripetal force. Well, first of all, always acts at right angle to motion. Right angles to the motion. Right, that's fine. So the centripetal force is going to be acting in here, acting in here, acting in here, acting in here. It's always going to be at right angles to the motion. And also the centripetal force acts towards the centre. It's the centre of the circle. Because it's going in circular motion, so that it's always going to act towards the centre of the circle. Now from Newton's second law, force is equal to mass times acceleration, we know we can work out the size of the centripetal force. Force centripetal is going to equal the mass times acceleration times the centripetal acceleration. Centripetal acceleration. So force centripetal is going to equal the mass times, well, we said the centripetal acceleration is v squared over r. So the centripetal force is going to be the mass times the velocity squared over the radius. So let's do this. This is kgs, mass. This is velocity, meters per second. This is radius of circle. That's going to be m. So if we do the dimension check on this, we're going to end up with kgs, meters squared per second squared per meter. Cancel. Equals kg meters per second squared, which is equal to newtons. So the force here, centrifugal force, is going to be measured in newtons. So we'll do a couple of examples with these in a second. So the big things we have to remember here is the acceleration is related to how fast we're going, actually the square of how fast we're going, and the radius, how tight the corner is. Hopefully that matches your life experience. From Newton's second law, force centripetal equals mass times acceleration centripetal, which is equal to mass times the velocity squared up. Okay, and this, two other things this is said. The force always acts at right angles to the motion, and that's what actually makes it go round in a circle, because the force is always making it go that way. And the force acts towards the centre of the circle. So let's go and do a couple of examples. See you shortly.